We are in our second video for sequence. And in this video, we shall practice how to interpret the general term of a sequence, how to produce a few terms of the sequence, and then later on, we shall practice how to obtain the general term of a sequence, given a few terms of the sequence. Okay, example 2.1, generating some terms of a sequence. So the general term is a sub n is equal to 1 plus 3 times the quantity n minus 1. Let us produce the first 4 terms. So how do you do that? Okay, so that is just simple substitution. Our first term, a sub 1, is 1 plus 3 times, okay, so it's going to be 1 minus 1, so that's 0. So our first term is 1 plus 0, it's 1. Our second term is a sub 2, so that's going to be 1 plus, okay, look at that, 2 minus 1. 2 minus 1 is 1. So this will be 3 times 1. So 1 plus 3, that's 4. A sub 3. A sub 3 is 1 plus 3 times 3 minus 1. 3 minus 1 is 2. So this is 6 plus 1, that's 7. And for a sub 4, it's going to be 10. Okay, so that is how we interpret the general term, and that is how we produce the terms of your sequence given the general term. What is the 15th term? So the 15th term is simply 1 plus 3. Okay, so you will look at the general term. Okay, so 15 minus 1, that's 14. So 3 times 14 is 42 plus 1 is 43. How about this? A sub n is equal to all of negative 1 raised to n minus 1. So be careful with that. Over 2 to the n. You know what? Terms that contain this produces a pattern which impressed me when I first saw it. When I first saw it, when I was about your age, I was kind of impressed. So let us produce the first 4 terms. So a sub 1. So negative 1 raised to 1 minus 1, that's 0. Negative 1 raised to 0 is 1. Okay, and then over 2 raised to 1 is 2. Next, a sub 2. A sub 2 is equal to negative 1, all of negative 1 raised to 2 minus 1. Okay, look at that. 2 minus 1, so that's 1, divided by 2 raised to 2, so that's 4. So negative 1 raised to 1 is negative, so it's going to be negative 1 over 4. So look at what's happening from being positive. Our next term is negative. Okay, what about the third term? Let us look at the third term. So a sub 3 is equal to negative 1 raised to 3 minus 1, that's 2. And negative 1 raised to 2 is 1. Over 2 cubed, that's 8. Okay, look at the pattern here. Positive, negative, positive. So you already know. You already know what's going to happen in the fourth term. You know it's going to be negative again. So this kind of sequence, we have a special name for this. Whenever you see terms with alternating signs, okay, the signs pertain to positive, negative, positive, negative. So when your sequence shows alternating signs, we have a special name for that. We call that an alternating sequence. And the part of the term that you must pay attention to is this one. All of negative 1 raised to an exponent. It can be n minus 1, it can be n, sometimes it's n plus 1. This is like a hint. When you see a term containing this, right away, you know it's going to produce a sequence whose terms show alternating signs. Example 2.3, finding the general term. So this is different. We are given a few terms we shall obtain the general term. The general term is like the formula, the rule that will tell you the elements of the sequence. So 5, 10, 15, you know the next one. The next one is 20, then 25. So what do you call that? Well, we call them multiples of 5. Okay, so how do you write a multiple of 5? Okay, so this is how you write it. A sub n is equal to 5 times n. How about this one? So this one can be a bit challenging. Again, I don't want to make it appear that it is easy to get the general term. If ever I am proceeding smoothly, that is because I prepared for this video. So my answers are already available. But in your case, if you find yourself getting stalled, you can't move forward, that is just fine. That is usually the experience of students when they are looking for the general term. So what is the pattern here? 1, you can look at 1 as 2 over 2. 1, 2 over 2. 3 halves is 3 over 2. Now look at that. 2 is the same as 4 over 2. 4 divided by 2 is 2. And then 5 halves is just 5 halves. And then 3 is 6 over 2. So the denominators are constant. It's 2. But the numerators, look at that, from 2, 3, 4, 5, 6. The next terms would be 7 over 2, then 8 over 2, 9 over 2, so on and so forth. Our general term here is a sub n is equal to n plus 1 over 2. The denominator is constant. But our numerator, we began with 2. It's going to be n plus 1. If you want to check if the general term that you obtained is correct, all you have to do is, using this general term, check out, see, will this produce the same first 5 terms? Check it out. So a sub 1 is 1 plus 1, that's 2 over 2, that's 1. A sub 2 is 2 plus 1 over 2, that's 3 halves. A sub 3 is 3 plus 1, that's 4 over 2, that's 2. Look at that, 1, 3 halves, and 2. Okay, that's it. 1, 3 halves, 2, so on and so forth. So we got it correct. It's a sub n is equal to n plus 1 over 2. Now, how about this? Again, finding the general term. So we have alternating signs here. So right away, your general term must contain this expression. -1, all of -1 raised to an exponent. Well, look at the denominators. Again, it's easy to see the pattern. 2, 3, 4, 5, 6. But you begin with 2. So a sub n is equal to n plus 1. No. A sub n is equal to, okay, -1 raised to n plus 1 over n plus 1. Again, if you want to check if this general term is correct, if this is the general term behind this sequence, all you have to do is use the general term and see if it will produce the first 4 terms of our sequence. Okay, so let's try it. A sub 1, -1 raised to 1 plus 1. So that's 2. -1 raised to 2. All of -1 raised to 2 is 1. So that's it, 1. And then over 1 plus 1. So that's 1 half. A sub 2 is a sub 1. No. A sub 2 is -1 raised to 2 plus 1. That's 3. So you know it's negative. Okay, so that's why you have a negative sign there. And then your denominator is 3. What if our term is the third term? The third term is a sub 3 is equal to, okay, we will use it again. 3 plus 1 is 4. -1 raised to 4 is +1. That's it, 1. Over 3 plus 1 is 4. So this is our generating term for the sequence whose first 4 terms are this.